We met up and had lots of wine, and I think that's how our friendship blossomed.
It seems that we might actually have human upgrades ourselves.
Always sounds like very dystopian.
The first ever CRISPR gene editing medicine has just been
I've got
approved.
an identical twin, so I'm just like set up for life.
It specifically edits our own genes.
This is basic Mendelian genetics. We should know this.
Edit the DNA and then put the cells back in the patient.
Damn, I was happy about finishing my little study and I'm listening to this. Like, I need to up my game. If you could edit one thing about yourself, what would it be?
And it's just like one big toenail.
What? I've literally been holding this in for weeks to tell you about it.
You read my mind, Yaz. I'm going straight on Insta.
Oh my god, guys, this account is fake. It's catfish. There's actually a guy running the account, so it's not
No.
a girl. No, it's literally.
What?
Yeah, it's mad. Can you imagine if you just found out that, like...
You're listening to the So Cultured podcast, where we bring you the latest science and tech goss, served with a side of piping hot laboratory.
We're your hosts, Liv,
Yaz and Taz.
three girls with a passion for science and tech.
Look, we've got the credentials, so we should know what we're talking about.
We're asking the dumb questions so you don't have to, and obviously all opinions are our own. We hope you guys enjoyed today's episode, and let's get into it. Hey everyone, welcome to our first episode of So Cultures.
Yay.
We're so excited to be bringing you this brand new podcast. This has been a few years in the making, kind of, because we've been discussing it for so long. So we're so glad that we are finally bringing it to you guys. So to start off episode 1, let's give some introductions and also just tell the listeners what they can expect from this podcast and what the podcast is going to be about. So Yaz, do you want to go ahead and introduce yourself first?
Yep, I'm Yaz. I'm a marine microbiologist. I'm in my final year of my PhD, and I study how tiny microalgae called diatoms can sense their environment. And I also run an Instagram page where you can find me at Marine Biology with Yaz, where I talk about what it's like to do marine microbiology and communicate science. What about you, Taz?
I'm Taz. I got my PhD about 2 years ago now, and I studied lyssaviruses and rabies and how we can create a more cross-reactive vaccine. Since then, I've been working on coronavirus, specifically SARS-CoV-2 in animals, and also looking at like transmission studies as well. And I've recently just moved to Australia to pursue an academic career here. You can also find me on Instagram at taz.phd, where I talk about PhD life and post-PhD life and just give you general tips and tricks there as well. Yeah, so we've got a marine microbiologist and a virologist. However, I am a bioinformatician, so I'm hoping to bring the tech side of things to this podcast. However, I still am in science, so I'm a bioinformatician, and I recently got my PhD in epigenetics, and now I am a postdoctoral researcher still working on epigenetics, and specifically I focus on a disease called motor neuron disease. And you guys can find me on Instagram at a genomics PhD and TikTok and YouTube as well. So yeah, that's a nice roundup of all three of us, or an introduction to all three of us. But Yaz, do you want to give the listeners just a little bit of background? So tell them about why we started this podcast and how it all came about, or how So Cultured came about.
Yeah, we met on Instagram, so we were all like posting about our lives, and I don't actually know how we started to become friends, but we randomly made a group chat, us three, and then we did meet up in person, and it was kind of like where you meet your online friends and you're like, wow, you're real. And we went to a rooftop bar, had loads of wine,
That was so
and
good.
we just got on so well. Like, I think we just kept getting bottles. We were just like, let's get another. And it was so nice. And then we obviously had this group chat, and we would just talk about anything and everything, always about new things going on in science or our experiences in our STEM fields. And then we just feel like we wanted to share that because we always have such, we find it interesting, and we hope that you guys do too.
Yeah, we think we're interesting. I don't know if we actually are.
We'll find out.
Yeah, we will find out pretty quickly once the ratings start flowing in on Apple. But yeah, no, I love that you mentioned the wine, because when I think about us three, like I always picture that picture of us three sat there with like the wine glasses in our hand. So Taz,
maybe you could give an overview of kind of the structure of the podcast, so how all of our episodes are going to go, what we're going to be talking about, and if you could give them the rundown on the science and the laboratory as well.
Yeah, so we basically wanted to create a space to talk about science. So each week we're going to bring you new episodes where we delve into brand new topics on science or tech. And then we are going to talk about more contemporary stuff, more fun stuff. And that is our section that we call laboratory time, because we are going to be spilling the tea every week, guys. And we really want to get you involved on that section of our podcast. So we will be asking you to write in each week if you have any gossip to spill. But yeah, we just wanted to create a space where it's quite chill. We talk about new developments in the science and tech fields so that majority of people can understand. And then, yeah, we just wanted to end on a fun note where we talk about gossip or just like have a general chit chat each week. So yeah.
I don't know about you guys, but I do love listening to science podcasts. Like, they're my favorite thing to listen to. But sometimes after a week of seminars and reading some really complex scientific papers, I just want to listen to a really chill podcast that's just breaking down everything really nicely for me and making everything really easy to understand, but also like making me laugh. So I think that's where we saw kind of like the gap in the market, if you like, in the podcast space, was to have a really like fun, silly, but also educational podcast. So we hope you guys will learn lots and also laugh even more while you listen to us.
If you enjoy, then please subscribe and share. So tell a friend to tell a friend, because it all definitely helps. And we will be releasing new episodes every Wednesday. So if you would like to follow us along on this journey, you can find us on socials. So Instagram is @SoCulturedPodcast, and you can find us on X @SoCulturedPod.
So yeah, as you mentioned in our little introduction, that you are now in your final stages of your PhD. How are you finding it?
Honestly, it is stressful. I don't think I've experienced stress like this. And I think you girls are going to know because you've been through this experience.
Yeah.
But I feel like I'm just overwhelmed. I think that's it, pretty much. But on top of that, my laptop has decided to absolutely die on me when I need it the most.
Oh no.
That is not what you need.
So I'm really just trying to figure out if I need to just purchase a new laptop, do like a big upgrade. But it's a 2015 Mac, so I think it is definitely due to like, it's done its time. It's survived through my undergrad and my masters.
I'm literally the worst person to talk to about this, because you guys know I love tech. I love new tech. So I'm absolutely gonna encourage you to make this purchase. Whether it's for the good or not, I don't know. I'm gonna encourage it anyway.
Yeah, literally. If anything is gonna make you write your thesis more, it's gonna be a brand new laptop. It's gonna motivate you to write.
You keep telling yourself that, guys.
I think that is it. It's literally like when you buy a new gym set or something, or like new trainers, and you're like, yeah, I'm going to go to the gym extra because I get to wear this new stuff. Like,
that is me all over. Literally, if I'm feeling demotivated, I'm like, yeah, let me just get myself a new sports bra. And then I'm like, yes, I'm so excited to go to the gym and wear my new sports bra. It's so sad.
That will be me with my new laptop. So hopefully if I need, I think I just have to like bite the bullet and do this upgrade, even though it is so expensive. But I think it's like a needs must.
Go for it.
Okay, well, actually, talking of upgrades, that kind of nicely leads us on to our science topic for today, because it might be that humans now have their own software upgrades.
Ooh.
Let's get into it. The first ever CRISPR gene editing medicine has just been approved by the Food and Drug Administration in the US. It's a pretty huge deal as it specifically edits our own genes.
Oh, how futuristic. It always sounds like very dystopian when I hear about like gene editing. I feel like that's how a lot of like non-scientists view it as well. Very dystopian.
Yeah, I feel like there's a lot of moral dilemmas that sort of circulate gene editing and stuff like that. But I know you've been using like CRISPR in your research, yeah. So
Do you want to just give a breakdown of how that works first, and then we'll delve into what this has been used for and things like that?
Yeah, definitely. So even though I work in marine microbiology, I use a lot of molecular biology techniques. And one of them is CRISPR, which stands for clustered, regularly interspaced short palindromic repeats. Honestly, I nearly
That's
didn't
such
say
a
that.
flex. That is such a flex that you know that.
Yeah.
You go to a bar and be like, this is my party trick. So essentially what CRISPR means is it is a type of technology that can genetically edit your DNA. And normally when people think of this, they might think of these shows that are on Netflix where they're a bit almost insane, that they're just trying to like make themselves go fluorescent. In my research, the way that we use it is so we can understand what gene and protein function is. So if you want to learn a little bit more about how CRISPR works, essentially you imagine you've got your DNA, which is the building blocks to your life, and this DNA encodes for proteins that help us function. And so with CRISPR, if you imagine your DNA is like a long piece of string, and you take a pair of scissors and you were to snip or cut in a certain area, you would essentially be editing that part of the DNA. It would then be like a lot shorter because there's a cut or there'll be some changes in it. And then that would affect how our proteins function. And so in my research, I'm not making superhuman crazy things. I'm just trying to study what these proteins actually do.
Nice.
That sounds so interesting, Yaz. I feel like whenever I think about CRISPR, like I said, my mind always straight away goes to like dystopian things. So it's really interesting to hear how you're using it, because you tend to think of how these things can be used for evil or for bad. Like people typically think about like designer babies and stuff. So it's really interesting to see how you're using it to actually like benefit and further our understanding of like how science works, right? So yeah. That's really cool.
Thanks. So yeah, that's how I use it. And it is just really understanding functions. But Taz, let's try and break it down and understand what this new technology is and how they're using CRISPR in a way to help benefit us with medicines or...
Yeah, so basically it's a new treatment called Casgevy, and it treats sickle cell disease. There is also another approved gene therapy based treatment called Lyfgenia, but it doesn't use the CRISPR technology. So we'll delve into both of those. But yeah, it's aiming to treat sickle cell disease, and hopefully this paves way for new innovative treatment for other genetic diseases as well.
Yeah, definitely. So can we maybe start with what exactly is sickle cell disease? I've definitely heard of it before, but maybe just a little bit of background for me, Yaz, and the listeners as well about what exactly it is.
Yeah, it's super common. So sickle cell disease is basically a group of inherited red blood cell disorders. So basically our red blood cells contain hemoglobin, and that is a protein that carries oxygen. So healthy blood cells are round and flexible, and they easily pass through blood vessels to carry oxygen to all parts of the body. But in someone who has sickle cell disease, this hemoglobin is abnormal. So that causes the red blood cells to become hard and sticky. And it's named after the farm tool, which is called a sickle, because it's C-shaped.
That's interesting. I don't know what a sickle is. I feel like I need to Google an image of a sickle tool.
It's honestly like a round, sharp blade.
Okay, I advise all of our listeners to go and Google image
don't know what it
search
looks
sickle.
like.
Isn't it like a crescent moon shape, or no? Is it like more...
crescent moon. Yeah. So that's essentially what the red blood cells look like. But because they obviously changed in shape, they get stuck and clumped together in like the narrow capillaries in your blood vessels. And they also die early. So that causes a constant shortage of red blood cells as well. So that can cause things like extreme pain, and it deprives areas of the body of oxygen as well. So it also makes people susceptible to infections, kidney dysfunction, anemia, and strokes.
Yeah, I've heard of it, and I feel like it is really common. But do you have any numbers for us on how prevalent it actually is?
Yeah, so a paper I read basically said that there were 500,000 babies that were born with sickle cell disease in 2021. And in that same year, 34,600 people died from sickle cell alone. But they did also estimate that 373,000 deaths were as a result of something else, but sickle cell disease was likely to play a really significant factor in the death of those. So it was like a comorbidity, basically.
Damn, I'm not gonna lie, I wasn't expecting you to say that many. So is there like several types of sickle cell disease, or is it just like one disease? Because that seems like a really large number.
So there are a few types, but essentially you have sickle cell disease if you have 2 mutated forms of the hemoglobin gene from each parent. And you can also have what's called the sickle cell trait if you just have 1 mutated hemoglobin gene from one parent and 1 normal gene from another parent. So people with the trait tend not to show signs of disease, but if they do, it's usually due to when the body's been under stress. So, for example, severe dehydration or like strenuous activity.
So people with the trait, do they just like have to learn to live with the disease, or are there current treatments available? And how does it differ between like people who have the trait and then full-blown disease?
People with the trait tend not need treatment because it doesn't tend to affect their daily lives. It is, like I said, only when you're under your body's under certain stress.
Yeah.
But obviously for sickle cell disease, that can be really debilitating. And current treatments are mostly like prevention.
Sorry, can I ask a quick question?
Yeah.
So, you say like people with the trait, like they'll only kind of like see the effects if they're under certain conditions. And you said like strenuous exercise. How strenuous are we talking? Like running a marathon, or like, I don't know, going on a jog?
I'm
know?
honestly not sure. I think it was obviously going to depend on the person, I think. But I think it's essentially going to be an activity that causes, like, I guess, your heart rate to increase,
Yeah.
you to need oxygen, or in times where you're in like oxygen deprivation, like that's when it shows, I guess.
So
Yeah,
I guess as well, like being in like high altitude is a problem as well. So they can't do like a
exactly.
mountain hike or something.
Yeah.
Yeah, that makes sense. Sorry. So yeah, current treatments. What is actually available for people?
So people with the disease, their treatment is mostly prevention measures because there's no like real cure, and apart from the one I'm about to delve into later, but the main measures are prevention. So blood transfusions from healthy blood donations, and also you can get certain medications that prevent the sickle cells clumping in the blood vessels. So they're the main treatments day to day. So there is one cure, but it's like quite a extensive treatment, and it involves a bone marrow transplant from a healthy donor.
And so you say bone marrow, like how do you actually get that and able to transplant it? And also you mentioned it's a cure, so is that just a one-time thing?
Bone marrow is like the soft fatty tissue inside the center of the bones, and that is where the red blood cells are made. So what they'll be doing is replacing the patient's bone marrow, which is where the red blood cells are made, with healthy bone marrow from a healthy donor. So basically, this patient won't have the hemoglobin mutation in their cells. So if you take out the bone marrow from the patient and replace it with the healthy cells from the donor without the mutation, then it should generate red blood cells that have a functional hemoglobin protein. And the way that you can take that from a healthy donor is usually they give them a number of injections to release stem cells from the bone marrow. They harvest those stem cells and then they give them to the patient after the patient has been stripped of their bone marrow. And that is usually done by really high intense chemotherapy to get rid of that.
Damn, that sounds painful. Because also, there's a reason I went into environmental science. I hate blood. Like, I literally can't deal with injections or seeing blood or anything. So, is this something that, like, there's a list of donors, or who are normally the donors that you could get this from if you
Yeah,
suffer
that's what I was thinking, because like typically it's like a family member, right? But when it's like an inherited like genetic mutation or something. I don't know, like how, yeah, I'd be interested in that as well.
For the transplant to work, the bone marrow has to be a really close match. And like you said, the best donor is a brother or sister. So yeah, they would need to not have sickle cell disease in order for that to work. So that is another implication of doing that. But that's obviously how the treatments that I'm about to talk about differ.
Quick question on that. Like, so you said they can't have sickle cell disease. Does that mean they also can't have the trait?
Well, it would mean that whoever's receiving the bone marrow would then have the sickle cell trait. They wouldn't have
Right.
sickle cell disease, but they would have
Yeah.
sickle cell traits. It's like, is that really worth the risks of a bone
Yeah.
marrow transplant to still have
Mm.
that? So,
Mm.
Because to have the actual disease, isn't it a recessive? Is it a recessive disorder?
yeah.
And that's where like you will see the trait, and then you will only see the disease when you've got 2 mutated copies.
Yeah.
Yeah.
So there is a 20.
Guys, this is basically like, this is basic Mendelian genetics. We should know this.
So there's a 25% chance that an offspring would not even carry the trait. So that's basically the stats that you'd be looking for to have a sibling that would not carry a trait at all, to be a healthy, healthy donor.
Yeah.
So do they have to do like, surely they must do like genetic testing before like bone marrow transplants, for example?
Oh, yeah, they would definitely.
Yeah. So that's just like an added cost.
Yeah.
Honestly, though, I have some kind of blood disorder. I don't even know what it is. It's like a sickle cell trait, but it's not. Like, I don't think there's even any research. But when I was a baby, I had to be tested in a sickle and thalassemia. I think that's what it's called.
Mhm.
Department. So I carry a little card around with me. So I think if I was in an accident or something, people would know that I could only receive certain blood or whatever.
Yeah.
So I think you do
Interesting.
get tested. So because it's hereditary, I feel like you're naturally going to be tested. Oh, I don't know if that still happens.
Yeah.
That was like
No,
30
there
years.
isn't there like
it's
a
actually a really simple test. Like, all you need to do is take blood, look it under the microscope, and then you can see whether the cells are sickled or not. Like, that's literally how I think really a
because
really easy way of diagnosing it.
did you guys learn about like in your degrees there's like a set of tests? I'm sure this is a thing unless I've absolutely made this up in my head, but I'm sure there's a thing where there's like a group of tests that like every baby has when they're born.
Yeah.
Like it's the, you know, when they get like a, what's it called, like a prick on their finger, take a bit of blood, and
Finger
then
prick,
they do a load of tests with that. Am I making that up, or is that a
No,
thing?
that's just like a standard blood typing test.
Yeah, so I wonder if it's involved in, it could be involved in something like that. I don't know. Who knows?
Maybe. I don't know. Maybe that's something that we need to look into and see.
Yeah, if we're ever gonna have a baby, we should probably know this.
I've got an identical twin, so I'm just like set up for life.
Oh yeah. What
Like,
the hell?
I'm good. Okay, so Taz, can we delve into a little bit about how these new treatments actually work then? So how does the CRISPR and sickle cell actually come together, and now it's given us this treatment?
Yep. Basically, the main point to take away from this is that it wouldn't have to be someone else's cells.
So me having an identical twin is pointless for this.
Yeah. Pretty. So
I'll let her know.
yeah. She's off the hook now. She's
I don't
not
need
an
to.
organ or bone marrow donor anymore.
Or I mean, she could still be an organ donor. Let's not take that off the
True. I don't want to be too horrible to her yet. I might need her later on in life. Might need a hip replacement or something. I'll just take her.
I
don't know.
don't think she'd give you her hip. Like, I don't think.
She could. My body wouldn't reject it, would it not? I don't know. I feel like I should know more about this, but I don't.
DNA. No, you are genuinely set up for life.
Yeah, I literally am.
Actually, to be fair, like in your case, it probably would be easier just to use your sister's.
What, her hip?
Her blood.
Oh, I don't know.
Anyway, back to it. Let's hear about the
Sorry.
technology.
Okay, so it doesn't have to be someone else's cells. Got it.
Yeah, basically, it still unfortunately requires a bone marrow transplant, but Doctors will basically be able to take the patient's own bone marrow cells out of the body, edit the DNA, and then put the cells back in the patient. And then from that, they'll be able to produce healthy blood cells from their own bone marrow stem cells. Yeah, it's really fascinating how we can just edit the DNA of living organisms, including our own cells now.
Okay, guys, pause. I think I have a bit of a dumb question.
There's no dumb questions in science, so ask away, Liv.
Okay, cool. That makes me feel a little bit better. So I don't know, I kind of get it and I don't. So I do understand how you can take cells out of someone, right? You can put them in a petri dish, you can edit their DNA and all of that. That makes sense to me. The bit that I don't understand is how you can then put it back into a patient and you actually see the effect in their body, if that makes any sense. Because obviously cells die. So don't the cells that you've just made the changes to, don't they just die?
No, I completely understand. That's such a valid question to ask. I feel like when you're talking about these bone marrow cells, they're actually stem cells. So they haven't yet been specialized and they have the ability to specialize into the blood cells. But once the cells go back into the patient, they are able to divide and they can proliferate that way. So they don't just die out.
Mm. Okay, but then don't you have like an issue with, because they're still amongst the unmutated cells, right? So then you've got healthy cells and mutated cells in the patient. Is that right?
No, essentially, this is what is so harsh about bone marrow transplant, right? So you'll take the patient's unhealthy cells out, you'll edit them, and then you will strip the patient of their mutated original cells, and then
okay.
you'll give them the edited cells back. But you make
Okay.
a really valid point, because with Casgevy, they still leave the mutated hemoglobin in there. They've done something really interesting where basically when you're developing as a fetus, you actually develop a fetal version of hemoglobin. And when you're born, this fetal hemoglobin is switched off. So it's no longer produced. And what they've basically done is they've edited the DNA to switch on this fetal hemoglobin, which is not affected by the mutation and is actually way more effective at binding to oxygen than adult hemoglobin. So essentially, you're turning on this gene, which is then going to make a functional fetal hemoglobin, which is more effective than adult hemoglobin. What that does is that dilutes out the dysfunctional adult hemoglobin. So you have normal, healthy red blood cells circulating.
Okay, that makes sense.
I definitely remember that from either undergrad or my schooling education and stuff. There was this curve, this sigmoid curve of like looking at
Yeah.
how it can bind more. But that's so crazy. I didn't know that it wasn't affected by the like mutation.
It's really interesting how something like that is switched off after birth, and then we just use an adult version of like the same protein.
Yeah.
So I would really wonder why that was even a thing, to be honest.
Yeah,
like
maybe we should aim to cover that in a future episode, because I'm really interested now as well. Like, what is the evolutionary advantage to us doing that? Because there has to be one, right?
Yeah, and you're an
epigeneticist. Do you know what? Like, as you've just said that, as you were just speaking, you mentioned about how they're like turning off this gene. And in my mind, I was thinking, like, is that not just rather epigenetic editing rather than genetic editing? But then I don't know if there's a version of CRISPR where it's like genetic editing, but it has epigenetic effects, if that makes sense. So I don't know.
Sure.
That's also interesting.
Yeah, because it's affecting the expression of a gene, isn't it? So
Yeah, exactly.
I should also give honorary mention to another technology, which is Lyfgenia, and it works slightly differently to CRISPR, and it works through a virus vector, which is a little
Is that
bit more.
Lyfgenia? Is it Lyfgenia or
Lyf-
Lyft? Have they named it after me or
No, it's LYF.
LYF? Got it.
Genia. Sorry to rain on your parade there. It's not named after you, Liv Sots. Virus vector is a little bit more up my alley, but I have to say, I think the Casgevy one might be slightly better in terms of like how well it works and like the limitations and stuff. But essentially how the virus vector works is if you imagine a your standard virus. You can imagine coronavirus if you want. And on the outside, you have the glycoprotein or the spike protein, which allows the virus to enter cells. And then inside the virus, you have the DNA encoding the virus, right? So the way Lyfgenia works is instead of having the DNA that encodes the virus, you have DNA that encodes a functional hemoglobin gene. So instead of delivering the virus genome to the cells, you're delivering a functional hemoglobin gene to the cell, and it gets integrated into the DNA of that cell.
So if they're using a functional gene, how have they obtained that if they're not using CRISPR? Where would you get a functional gene, or is that just like a synthetic?
Yeah, it would have just been synthetically made. Yeah. So just like Casgevy, the original mutated hemoglobin is still present, and the artificial functional hemoglobin dilutes out the sickle hemoglobin that is present. So yeah, works in a similar way.
So is that similar that if you've got a trait, do you also still have some abnormally shaped hemoglobin, and that's why you get the effects after like the strenuous activity?
Yeah, so with the trait, I think you still do have sickle cells present, but they're obviously not as numerous as if you have both mutations.
So with this Lyfgenia treatment, it's essentially like you'd have the trait because you might still have some present that have the mutation.
That's a really good point, and honestly, I'm not sure. But I imagine so, because it's essentially the same thing, right? You still have mutated forms and you still have functional forms. So yeah, I'm gonna go ahead and say yes. But if you're listening, you can fact check that.
Yeah, super interesting. It's mad how science has just evolved and people are doing some crazy.
I was literally just thinking like, damn, I was happy about finishing my little study and I'm listening to this. Like, I need to up my game because my science is not on par. But then I have to remind myself, okay, this was probably a huge group of people, like tons of years.
Don't forget, like, it's off the back of like so many other technologies that other people have discovered. Like, it's like an accumulation of like people's
whereas
like time work.
Whereas if you're like the first person like working on something like Yaz, oh my god, the algae that Yaz you work on is mad. Like I did an RA position during my PhD working on the same algae? Yeah, I did this little project working on the same algae that Yaz works on, and honestly it was so difficult. There is like no data out there whatsoever, so like even doing a really basic thing like a goal keg enrichment took me weeks. Like it was such a nightmare.
Yeah, and I think that's a really interesting point because it makes, sometimes I feel like my research, I'm just trying to understand gene and protein function, but obviously in the case of this treatment, they had to know what genes are responsible for causing this abnormality, and that would have come like ages ago, but you need all of that fundamental research to develop technologies like this. So I think it kind of puts your research into perspective that, yeah, while we're doing PhDs or postdocs, you might not think it's as groundbreaking, but you never know, in like 10, 15 years time, maybe something could come from what we've done.
Definitely.
Yeah, definitely.
And also, let's not forget, guys, like this technology is still in its early days as well. Like it also does very much have a lot of limitations. Like it's been shown to be really effective. Like 93% of patients with Casgevy did not then experience symptoms of the disease for a 12 month
Wow, that's
period.
good.
And Lyfgenia, it was 88%. So it was very effective, but there were some like major limitations, such as you still have to do a bone marrow transplant, which uses like really high dose chemotherapy. In fact, like I think some patients died from the chemotherapy process, and this type of chemotherapy can also render women infertile. There's a lot of limitations. I think also from Lyfgenia treatment, there were like blood malignancies that occurred in some patients. So if you got that treatment, you would then have to be monitored for the rest of your life. So like you really do have to weigh up the pros and cons of this as well.
Yeah, definitely. One con I always think about is like accessibility of any new treatment, right? So like, do you know like a ballpark how much it actually costs? Because I know we were talking about like, oh, you might have to get genetic testing for all of your donors and things like that. So I think so many things factor into it. So yeah, how much does it cost?
I think they said a ballpark figure of about £2 million. So
Okay, I was not expecting that much. That's crazy. 2 million.
That is insane, especially as sickle cell disease is really common in people with
Yeah.
Afro or Caribbean family backgrounds. So I think if you're trying to treat people in different economical situations or different countries, it can be really like, how do you even get this treatment? I don't even know, would this kind of treatment go onto the NHS if it worked? Like, I don't even know. I'm not in the, clinical and human trial development.
Yeah, I just think like obviously at this stage it's so inaccessible for the average person, and we'll just have to hope that further down the line it becomes more accessible.
Thanks for sharing about CRISPR with us, Taz. To kind of wind up the sciencey bit, I have a question for you both, just to finish off, which is, so obviously we've been talking about humans having their own software updates. So my question to you guys is, if you could edit, again, I encourage self-love. We're not hating on ourselves here, but if you could edit one thing about yourself, what would it be? Because I'm so intrigued.
Ooh.
Mine would be my feet. I hate feet. I hate toes. Like, don't put your bare there. Honestly, the sensation is just not acceptable. I just can't.
Wait, sorry, what? How are you gonna edit your foot? I'm sorry, or your toes?
What, you're just going to get rid of it?
I haven't figured that one out yet, but maybe either. I'm not saying I'd want necessarily like a webbed foot, although that could like be better for me. But I feel like maybe you just have like one big rounded toe, or like, in Spy Kids when people have that, some people, and they like walk around and it's just like one big toenail.
What?
I don't.
What if you wanted to get your nails done? That would be like some epic nail art on that one big toe.
Oh no, imagine the things you could do. You could put a whole painting on it.
I think that would be good. Like, imagine you just put a sandal on. And like some people actually, when they're out and you see them in high heels, but like a little toes hanging out the edge of the strappy bit, that would never be a problem because it's just all kept together.
You've really thought about this in depth. That was me like, oh, you know what? I would probably edit myself to have like 20/20 vision, even if that was even possible. And then there's you as like, oh, I would just get rid of my toes, to be honest.
I think that would be so great.
If we're like really trying it out though, I think honestly, like I would probably give myself wings.
I think
that's a good one. Yeah, take notes from Taz. She has good answers.
Liv, what would you do?
I would obviously give myself a load of muscle.
Superhuman.
I want to be jacked. Yeah, I want to be absolutely jacked. Those pictures of Hulk Hello Kitty. Have you seen them? I'm pretty sure
you'd love that.
Yeah, I love it. That's what I want to look like. I want to be absolutely jacked.
You're already jacked. Yeah, so that's everything for the science section of today's episode. And obviously, if you want to learn anything more about what we speak about on these episodes, then we'll always leave the links in the description as well.
I'll slip into your dreams tonight. Oh, so give me your
Guys, I have some super juicy gossip to tell you for this part of today's podcast. And I've literally been holding this in for weeks to tell you about it. So yeah, I have some piping hot tea for you guys.
The laboratory is here. I'm excited. Yes, I've been waiting. This is like my highlight of the week.
Yeah, it literally is the highlight of my week as well. And like I said, I've literally been dying to tell you guys about this. So you know how we have our little group chat where we talk about science and stuff, right?
Yeah.
I'm also part of this group chat on Instagram with a few other developers. So more people in like the tech kind of side of Instagram or like development kind of side of Instagram. We have all followed this account on Instagram for years. Like this account was like the OG like tech account, right? Her name was Coding Unicorn. If anyone wants to go and look her up, because the account is still active, right?
Hold on.
I'm going yeah. You read my mind, Yaz. I'm going straight on Insta.
Do it. Go on.
So I'm genuinely still surprised, like so surprised that this account is still active. But one day I was literally just chilling and I was working and I got a message pop up on my phone on this group chat with one of the girls put in the group chat like, oh my God, guys, this account is fake. So it turns out that this account, right, basically she's a tech account. She posts like loads of photos of her just like, at her computer or talking about coding and stuff. She's got 115,000 followers. So this is not a small account, like it's a big account, right? Mm-hmm. She puts in the group chat, this account is fake. It's catfish. There's actually actually a guy running the account. So it's not a girl. No, it's literally a man running the account, right?
What?
So we were all trying to hypothesize, like, why would anyone be like making a fake tech account? Like,
guys, if you are listening and you haven't gone onto this page yet, it is literally this woman just sitting with her laptop, her screen showing coding and stuff, and she looks really pretty coding, and like the comment, like the captions, actually it's like really informative. I'm just so confused.
And it's not AI, guys. Like, this is a legit real woman, I swear.
Right, because everyone was hypothesizing that it was AI, right? But my first thing is like, why would anyone, well, like I said, like, why would anyone want to fake this account? So I at first just thought it was jokes. I was laughing. I was like, this is so funny, because I low-key thought that the images, I mean, they're highly photoshopped, you can tell. So I was like, I think they're all just Photoshop. Like, I never really believed the account. She's only got like one video of her talking. So by the way, she actually does have a video of her talking. So that's why everyone thought the account was real.
What?
Yeah, it's mad. Can you imagine if you just found out that like one of our accounts are fake? That's literally what it was like for us, because we've all followed this woman, and like she's just kind of like in our creators circle, like in tech. So it's literally like finding out that Taz's account is fake and there's a man running the account.
Can I just say as well, like, they have like committed to posting way more than I ever have on mine.
Yeah,
They have
literally.
1,303 posts, and this woman is in every single post pretty much.
Literally. That's what
And
I'm
it's
saying.
like, could it be AI? Because like sometimes she's got glasses on and they're like the same glasses, or sometimes, or maybe they're not even.
And a
They're
mask
different.
and wigs. I'm
Oh.
literally scrolling so far back. I'm like,
It's mad. It's mad. Okay, so yeah, like I said, at first I thought it was jokes. Like, I was like, haha, this is hilarious. Like, she's catfish the whole tech community, like low-key funny. But guys, I actually started reading into it, and it actually gets quite deep. So obviously everyone was trying to figure out like who was behind the account, right? But the reason that anyone actually ended up finding that this account was fake is because I'm going to give you a little bit of a spoiler, because I feel like you need context, because I was very confused for a while about this. I was literally trying to crack this case because I was like, what? This is mad. So basically, the guy behind the account is this guy called Edgewards. I think that's how you pronounce his name. And he actually runs this huge conference that I think runs yearly. And the conference is called DevTernity. Guys, this conference is huge. I'm talking like hundreds of people go to this conference. It's something crazy, like £800 a ticket for this conference, right?
What? But wait,
And
how do you know who it is already? Like, how?
Okay, well, I'm going to get to that. Okay, so he's running this conference, this whole like tech conference. And basically the first hypothesis is that he actually started this account to create a fake influencer to promote his conferst.
oh,
Let me not lie. Like, that's quite smart, like marketing.
Okay, so you're literally going through the roller coaster of emotions that I went through. First, I thought it was funny. Then I was like, okay, low-key smart, like not ethical, but low-key smart that he's created this fake influencer to promote his conference. So if you go on her post, you will see that she's talking about DevTernity a lot, and that's the name of his conference. So she's promoting it. So everyone was like, yo, this is really bad. Like, he's literally made this a fake account and he's promoting his conference. So like people will buy a ticket, and the tickets are like £850 or something crazy like that. Like, they're
why
expensive.
did he promote himself? Like, that's a big question, isn't it?
Well, money, obviously. Like, he's going to get all the money. The more people who buy the tickets to his conference, the more money he gets. So that's why he's made this fake account, right? So it was all crazy. And then basically people noticed that this girl who is like the face of this tech account was actually on the speaker list at this conference. So she was supposed to be speaking at the conference. But what people noticed is that she had been on the speaker list for like the past like 4 years. And every single year she dropped out last minute because of like issues. So rather than just promoting the conference of like, this is a really cool conference that I'm going to, like, come along, she would actually be like, I'm giving a talk at this conference, sign up to this conference to come and see me give this talk. Yeah, it's like if I was to say, or like any of us, because obviously we've got like a following on Instagram. So there may be people who are interested in coming to see us talk. So if we were to like promote a conference, say we're giving a talk, people would buy the tickets literally to see us. And then like, if you just don't turn up, that's what it's like.
Girl.
When I said the tea is hot, like, I mean it. Like, there's more to this. Okay, so people start noticing that she's on the speaker list, she's dropping out. So everyone was like, what the hell? Like, why did she keep
Surely they
dropping
must
out?
be disappointed as well, because like they've gone
Exactly.
to be like a content creator that they really like enjoy, and then they're dropping out on the day. Like, that's annoying.
Exactly. I think this is how it all ended up coming out, because people were like, why does she keep dropping out? Like, this is that's
Oh.
weird. So then people started going on the, like, looking at the rest of the speakers list, and they noticed obviously there was very few females. And another thing that they noticed is that all of the female speakers were actually AI generated pictures, AI generated like abstract.
Can we appreciate men are going to the extent of making AI generated women? Like, there's women in tech.
Exactly. Okay, so everyone starts noticing all of the speakers on the like speaker list, they're all AI generated. They don't exist. They're like Googling them, searching them on LinkedIn. I think, to be fair, one or two of the speakers were real, but the majority, like, they're all AI generated. But all of the male speakers, they're all real. Like, they're all turning up to the event. So everyone's literally saying exactly what Taz is saying, is like, why is he going to the effort of generating these freaking AI women? Why does he not just get real women in tech? Like, it's weird. Like, I just don't understand it.
Okay, so you said the women are AI generated and this woman is like fake, but like, how did it all just come out?
What, as in, like, how did it link back to him? Like, how did everyone know it linked back to him?
Yeah.
Yeah, that's a good point. I feel like I missed that part. As I said, everyone was doing that. They're investigating, and they noticed that she like was on the speaker list. She kept dropping out. So people were looking on her Instagram, right? And there's a particular picture on her Instagram where she's got something in the background, and it's this kind of like thing on her wall that says, "Think outside the box." I'm going to give you a minute to go and find the picture. Yeah.
Oh my God. Okay. Yeah.
Okay. Then people go on his Instagram and they find the exact same background. So everyone was like, what the hell? The plot thickens. And then I thought, I wonder if I go on his GitHub. Do you guys know what GitHub is?
Yeah.
I've heard of it, but honestly don't know how to use it.
Okay, so GitHub is like where people put all of their code, like any code that or any projects that they're working on, like they will put all of the code on there. So sorry, I didn't go to his GitHub. I went to her GitHub, and I found in her GitHub, like in her code, his name. So I was like, what the hell? Why is his name in her code? There was loads of people on Twitter doing like little investigations into it. So I sent them the links to the code, and then everyone was like, wow, he couldn't even bother to take his own name out of the code that is on her GitHub.
You're actually part of this whole.
I know. This is what I'm saying. I was sat there literally trying to figure it out. But now the question that we're left with is, so some people think that this woman is AI generated, and then some people think that it's actually his friend who's posing in the pictures for him. And then some people, yeah, it could be. And that account actually follows another account whose name I'm not going to name, just in case it's not actually the actual woman. But the Coding Unicorn account follows several, like only a few accounts. It follows 11 accounts. And one of the accounts is the guy who everyone thinks is behind the account. And another one is the account who everyone thinks is actually the woman in the photos.
Oh my God, I can see.
Yeah? Isn't it mad? It's actually crazy. So now, yeah, everyone's like, is she in on it, or does she not know that she's being used to like catfish? But my guess is that she's got to be in on it, right? Because there are so, like you said, there's 1,303 posts. Like there are so many. She's got to be in on it.
No, 100%.
And like, the background is the same as what you've seen.
Exactly.
So I think he's using some like elaborate filter and like changing it to look like her. Like, can AI? I don't even know how AI works, to be fair. Can it do that?
I honestly think like, this is a real person. Like maybe they have Facetune, like something like that. But it goes back so long to the point where you kind of question, was AI like even prominent this far?
No, exactly. I feel like AI, like generative AI, so for example, like images and videos, like I would say only in like the last year it's really come into play, and it's only really in the last year got to a point where I think it is quite hard to distinguish AI generated pictures versus real pictures. So yeah, my guess is that she's in on it. But
yeah. I'm not being funny. If she is in on it, how much time and effort for her to pose in front of a computer or a laptop if she's not even like
right?
What the hell? Because I literally am like, oh, I should post today. But these are so many pictures in so many different locations with her like, fake typing on the laptop. Like, what is this?
Okay, guys. So to summarize so far, fake Instagram account. He has made this fake Instagram account to promote his conference where he charges people hundreds of pounds for tickets. By the way, this conference is loved. People love this conference. And the majority of the female speakers, they're all AI generated. So a lot of people were just like, why do you not just have real women in tech? Like there are so many great women in tech who do amazing things. Why are you not just inviting them to the conference? The reason that I think he has a hidden agenda is because I think this was like in 2021 or 2022. He actually does this interview with this this like tech blog where he is obviously posing as Julia. So Julia is the fake girl, the Cody Unicorn account.
Oh my
so
God.
he poses as her. And there's one question in the interview where he gets asked, if there's a bias women face, why do you think it is still there in the 21st century? What are some things people and organizations could do to change this? So basically they're asking him, or the fake, they think they're asking this woman, like, do women face a bias in tech? And like, what do you think people can do to change it? His answer, I don't like seeing women as victims because such a mindset turns men into suspects. Men that suffer biases equally to women. Think of job interviews. Then goes on to say, basically, we give way too much attention to gender bias. So he's posing it as a women saying this. And I was like, that is the moment that I was like, you have a hidden agenda. Like, you literally are just using this account not only to line your pockets with money, but also to belittle women's experiences of gender bias in tech. Like, it was
Can I
crazy.
just say, me and Yaz's jaw is on the floor. That's just so classic.
I know. And the crazy thing is, like, obviously he's been called out. This was all over like tech Twitter, and he was called out and he basically is refusing to admit anything. I mean, I haven't checked it recently, so he might have, but he, at the start, when there was so much evidence against him, he was literally point blank, like just saying it wasn't true, and was basically just like calling out everyone who was calling him out, saying that like they've destroyed his conference. Like, he was literally more bothered about the fact that his conference couldn't go ahead rather than explaining why he's been running this fake Instagram account to line his pockets and belittle women's experiences. Like, it was mad.
I'm just looking at the comments on the Instagram. One comment says, all of this when you could have just reached out to real women. Like, it's so true. It's so true.
If this came out and someone was like, Yaz, your IG is fake, I would literally put a story and like,
Exactly.
okay, tell me to go and grab things right now live. Do you know what I mean? Like,
Live. I would go on live, yeah.
When people say like the silence is so loud, like the fact that nothing has happened on that post, like on that Instagram, says a lot. Like, surely she should go on camera and be like defending her account. Like, no, guys, I'm a real woman.
Right, but this is what I don't get. If she's in on it, why don't they just do that? This is what I don't get.
Also, maybe they're just so shocked that people have just finally found out, because I'm not going to lie, I've scrolled all the way to the bottom and they've been doing this since 2018 and getting away with it, and it's only just come out now.
That's what I mean. That's why it's so crazy to me, because like I remember when I first joined like Instagram, it was literally like one of the first accounts that I saw. And I was like, oh, that's cool. Like, it's really nice to see a woman in tech, and like her captions are really informative and blah, blah. He's been writing them the whole time. In conclusion, we have to be really careful of who we're following on Instagram and who we take advice from, who you confide in. But we can confirm, me, Yaz, and Taz are real. I have met them in real life. They are real.
Yeah, we can vouch for each other, guys.
There's a man behind all three of us, imagine.
Dave. My name's Dave. Honestly, like, I'm so glad that you told us about this, because like, obviously me and Yaz are like not really in the tech world at all, but my gosh, that is actually scandalous. And
well, don't worry, guys, I'm here to bring you all the tech goss for the foreseeable future, and you guys have got us covered on the science goss.
And if you write in any goss that you've got, whether you've just found out something about, say, an undergrad in your lab, or a postdoc's doing some random crazy stuff.
I was literally about to say, I bet one of our listeners has a good story for us. So where can they email us if they have anything that they want us to discuss on the podcast? Obviously, we will keep everything anonymous, so no worries.
Yeah, so you can either find us on our Instagrams, obviously, or our So Cultured Podcast Instagram, that is at So Cultured Podcast. Or you can email us on soculturedpodcast@gmail.com.
And as we said, we will keep everything anonymous. So if you have any crazy stories, don't worry. We will keep it 100% confidential.
We may also have some juicy stories ourselves. So
yeah, you will find each episode on Wednesdays where we are going to bring you the latest in science and tech and all the laboratory.
That's a wrap on episode 1. And we will see you guys next week. Bye, everyone.
bye.
You've been listening to the So Cultured podcast. Thanks so much for tuning in.
Make sure you listen in next week for more science and tech updates and the hottest laboratory.
You can stay up to date with us in between episodes by following us on Instagram and X at So Cultured Podcast.
See you back here, same time next week.